Hey everyone. Thanks for joining me. This is super exciting. I'm really excited to come and talk to you live about the science behind Star Trek Discovery. If there are any issues hearing me or it's oversaturated or anything, please let me know. I'm still playing with the settings, but I appreciate you hanging out with me. We're going to have a really good time. I was super excited watching Star Trek on Sunday because I wasn't sure how much science there would be in it. And yeah, thanks. I'm really excited. I wasn't sure how much science there would be, and then it kicked off. And I kind of lost my mind because there was a lot of science straight from the beginning. So we've got a lot to talk about. So we're going to go right into it. Hopefully all of this is going to work. I want to thank Twitch for partnering me in order to do this educational content. And I also want to thank CE Philby and Lil Susie for subscribing to me before I even started, which is fantastic. And for those of you who might be interested, it is September still, so you get half off subscriptions, and I'm going to be rolling out the different bonuses for the different subscription tiers as we go. But you're not here to hear about that. You are here to talk about Star Trek Discovery. So let's do it. Like I said, when I started, I had no idea how much science there would be, and then this was one of the first shots that we came to after the Klingons, and I went, woo! I'm super excited because it looked like Mars. The big giveaways for me was that it looked kind of red. Because Mars' surface is oxidized, so it has kind of a red tint to it, just like this. The other thing that kind of was a big clue is that it looks like a lot of sedimentary rock, which is exactly what you would expect on Mars. We're discovering a lot more sedimentary rock on Mars because Curiosity is in this little crater, and it's looking at all the rocks, and it's seeing these layers. And the awesome thing about finding sedimentary rocks on other planets is that it means that there used to be standing water there. So Curiosity has found standing water on the surface that used to be on the surface of Mars, which is awesome. So as excited as I was to see this, it turned out that it wasn't Mars, unfortunately. The first giveaway was that they were walking without spacesuits. And if you were to walk without spacesuits on the surface of Mars, you would fry. But we're going to talk about radiation soon. So yeah, there they are walking around. So it's not Mars. We're on another planet. We are on some mystery planet. And there's lots of storms, there's lots of dust, which is similar to Mars, and there's lightning, which I'm going to get to in a second. But the cool thing is in this picture, if you look in the background, you can see that there's two objects that look like maybe a companion planet and possibly a moon. So we're talking about a three-body planetary system, which is a little bit weird because it's hard. So scientists originally, when we started looking at different planets and trying to discover exoplanets, basically we just wanted to find Tatooine. And we've not been able to find Tatooine yet, but we've got close. Because, so Tatooine, as you know, has 2 stars, and as far as we know, 1 planet. And that was really difficult for scientists to conceptualize because the physics of that is hard to do. So it's something called the 3-body problem, and it's really easy to have 2 objects that orbit one another because you have a center of gravity. As soon as you enter a third object in, that center of gravity gets all thrown out, and the most likely scenario, 99% of the time, an object's going to get flung away, which isn't ideal. So it's hard to come up with a 3-body system. Now, with stars and planets, we have been able to do it. And the 2 easiest ways are basically to have 2 stars that are in the center, and you have a planet orbiting them at such a distance that it basically sees the 2 stars as 1 star. Or you could have 2 stars that are really far apart orbiting one another, and a planet is going around one of those stars, and they're just so far apart that they don't really affect one another. And those are the easiest ways to have a 3-body system. So this looks like it could be a 3-body system. You have the planet they're on, the planet in the horizon, which, it's got a big radius. It, could be another planet or close to the same size. And then there's sort of a smaller object in the background, which we'll call it a moon. So, I saw this. I was like, okay, that's kind of cool. It's a bit weird, but it's possible. But the problem is that then they did a camera shot from the front of them, and I watched it a few times trying to figure out if it's the same objects, but you actually see 2 more objects behind them, which means this is a 5-body system at least. And the physics of that is disgusting. If someone wants to code that and try to make it work, good luck. But given the relative size here, I'm going to say that is really, really difficult to do. So 5-body system, but Mars-like planet, even better. So carrying on from that, then they are talking about the need to get this water back on the surface, and there's some problem with the liquid, and they need to try to figure out how to restart this well that they're traveling to, so this species can continue to survive. And what they said is that the ambient radiation from a nearby meteor drilling dried out the water table. Ew. Yeah. Actually, 90%, I'm okay with that. And the reason that I'm okay with that is because we think that's what happened to Mars, basically, is that there used to be standing water on the surface of Mars. This looks like a Mars-like planet. And somehow, we don't know whether it just cooled off or whether there was a catastrophic event, but its magnetic field was destroyed, which meant that all the radiation from the sun plummeted the surface of Mars, which caused all of the water, which burned off the atmosphere, which meant that the water evaporated. So having an atmosphere kind of weighs water down, and then the water evaporated because there wasn't an atmosphere there. So this is kind of skipping a step because, as you can see, they're not wearing spacesuits. So there is an atmosphere again, but maybe, there was sort of a yin-yang type thing that happened here. So we're going to assume that ambient radiation somehow burned off the atmosphere, which would cause water to dry out, cause it to evaporate because you're in a vacuum. And then the atmosphere came back magically. Then they say, well, you need to fire your weapon in a unit called filibursts. That's new to me. We'll go with it. Into the water table. I wrote nonsense. It's maybe a little bit harsh. I don't think it needs to be that harsh. But they just shoot through the bedrock into the water table to expose the water again. And, that works maybe because there's an atmosphere again that we want the water to be back, which is great. And the cool thing about this is that we have actually discovered something similar on Mars, that there is a water table under the surface of Mars, and Curiosity has seen evidence of it, the little rover that's on Mars, but Curiosity also wasn't sanitized to interact with water because, and this is awesome, NASA and the other space organizations around the Earth follow the Prime Directive, which is don't interfere with other life. And that's cool. But part of that means if your probe or your robot or whatever you've got out there isn't sanitized, then you don't want it touching water. Because if you have any sort of bacteria or anything from Earth, and we're still trying to figure out how much stuff can live in the vacuum of space, and it's more than we think so far, you don't really want your rover touching a water table because you could spawn new life, which is weird and creepy. So water table under the bedrock, I'm good with that. The water table, or the water having been evaporated from nearby radiation, I'm good with that. So you can see why I was geeking out within the first 10 minutes of this episode because the amount of content they had here. So the next thing, there's a storm approaching. A dust storm. There's lightning in this dust storm. All of this is awesome. And on Mars, we have seen dust storms forever. As long as we've been able to observe Mars, we've been able to see that occasionally you get dust storms that envelop the planet, which is cool. Some of them are localized, but some of them actually get so big that they envelop the planet, just like the one you see here. And the Captain Georgiou actually throws out the concept that if they get stuck in that dust storm, they're going to be stuck there for 89 years. I'm still quite not sure where that came from, but we do have storms on Mars that last for ages and ages and ages. Now, the reason they last so long on Mars is because all the dust gets kicked up, and it's really fine like baby powder, and the gravity is so low on Mars that it kind of stays suspended. So you can imagine you get this baby powder and then it just hovers for ages. Now, another cool thing in this, there's so much. Another cool thing is the fact that we see lightning. And we didn't really think that we could see lightning on Mars before. It didn't seem to work. And since then, we've actually seen lightning in dust storms on Mars just from ambient static radiation, which is super cool. So, dust storm approaching. Some reason if they get stuck is going to be 89 years. I don't know if that was just a philosophical statement that Captain Georgiou was saying, but we'll go with it. And then she draws the little Trek thing, and their ship shows up through the atmosphere. I saw some people are really annoyed that ships keep coming through the atmosphere, but let's be honest, Star Trek has been doing that well since the 90s, so we're good with that. But there are no friction burns or damage of it coming all the way through the atmosphere, which again, Star Trek has ignored for a really long time. So we're just going to call it good. We're going to say that the shields somehow are okay dealing with this, and there's no problem. It does seem a little bit weird, but we'll go with it. So they come to rescue them, and then credits roll, and we all go, "Oh, it's a new Star Trek series!" So we see them at warp, and if you've seen any of my videos or hung out with me for any sort of time, yeah, Mohammed, good deflectors. That's it. If you have seen any of my talks about how warp drive works or faster than light travel, then this is sort of familiar. It's a combination of having a warp bubble and a wormhole type visual, which I like. And you also see the warping and distorting of space-time, which we geek out about. I always have a picture on my computer desktop of gravitational lensing that we get from other galaxies and other star systems, because it really looks like it's being distorted by some sort of weird camera effect. So there's a question here. If the universe is expanding, what's it expanding into? That's a really loaded question. We're going to keep going with Star Trek, but I'll come back to that if we've got time. And if not, I'm going to do an episode on it. So hang with me there. But I like that question, and it's a hard one to answer. So we've got warp drive. Warp technology has been around for ages. No problem with that. Star Trek we're happy with. And the one thing, Star Trek, when they started talking about stardates, and she mentioned, Michael said stardate 1207.3, and it was otherwise May 11th, 2256, a Sunday, which is great. But retconning, I was like, I don't think that that's the right conversion, and from TNG, we have stardate 0 is 2323, and this is before that. So we're okay. We're going to move on from that, but we may need to start doing our stardate calculations differently again. Thanks, guys. Okay, and then we kick off the story. This image shows up. I lose my mind. There's so much just in this little image that causes me to geek out. First, there's a binary star system accretion disk and interstellar comm relays that possibly were destroyed with an asteroid. Oh, I don't even know where to begin with this. Okay, so first of all, because this is a little bit easier, we'll go with the comm relays. So they talk about, we have interstellar subspace comm relays. Star Trek has used these sort of concept for a while, and we're okay with it. Subspace, that's possibly where things get a little bit difficult, but basically what you're doing is you're setting up a whole relay, and somehow you're using the gaps in space-time to kind of punch through so you're able to travel faster than light. And these interstellar comm relays are able to do that. Cool. Okay. Subspace communications. It's a sci-fi thing. It's a good way to do it. I could spend a long time talking about how that works. But essentially, you have the surface of space-time. If you want to travel along the surface, the faster you can go is at the speed of light. And if you want to go faster than the speed of light, there are a few ways you can do it. Some sci-fi uses quantum entanglement. Star Trek, using interstellar subspace comm relays, uses this idea that we have our universe, which is a sheet. And Tuli Cream, this is like kind of what you're asking. So our universe is like a sheet, and traveling on the surface is the speed of light, but you could have above or below that sheet is subspace. And so if you're able to kind of shortcut our universe in subspace, you could theoretically travel faster than light. So that's okay. The idea that it was damaged as a comm relay, that you can see a big hole punched through it, was kind of cool. And I'm going to go into that because now I can talk about this awesome star system that they've encountered. So, oh God, what we're seeing in the background is basically 2 accretion disks. I'm trying to get it right. 2 accretion disks. Mirrors, physics, science. Yes. 2 accretion disks as 2 star systems are forming. So when stars form, they come from a big glob of dust and gas called a nebula. And as that dust and gas exists, it starts kind of orbiting each other, and you get this snowball effect because dust will clump with other dust and then get bigger. And then that's going to have more gravity, and more dust is going to attach onto it. And those are going to get bigger, which makes more gravity, which makes more dust, and you get a big snowball effect. Hey, thanks for following. As that starts to get bigger, you can imagine the center of this big cloud is going to start to get really hot. And you've got dust and gas that's all really close and clumped together. And just like friction warms up your hands, the dust and gas start to warm up and from friction, and you basically get a star igniting. And that's a proto-star system at that point. So you have nuclear fusion going on in the middle, but you still basically have a big ball of dust and gas. Now, the reason that they're flat is because as it starts orbiting, we get angular momentum, and what happens is it starts, I'm going to do this here, as it starts to flatten out. So as stuff is spinning, angular momentum, right hand rule, creates a vertical force which flattens things down. And as it flattens, thanks for following, as it flattens, you start to get this disk. And again, we have dust and gas that's going on, and it's starting to clump together. And you start to get a star in the middle, and then you start to get planets forming from all that dust and clumpiness that's on the outside. Super cool. Now, binary star systems, one where we have 2 suns, we see a lot of binary star systems. This is a thing that we see in space all the time. Proto-star systems, which are kind of what we're talking about here, where we have a star has been formed, and then you just have an accretion disks where planets are starting to clump out from that. That's what we're looking at here for each star. But there's a bit of a problem. Okay, it's not a problem. It's just a complication. So like I said, when star systems form, they come from one big ball of gas and dust, which is a nebula. And sometimes that dust is going to clump into 2, and you get 2 stars that are orbiting each other. And then you get planets that start to form from that. But like I was saying with the whole angular momentum, you're going to get the stars in line with one another, and then the accretion disk is going to be in line with that. These accretion disks are not aligned. They are, one is like this and one is like this. So what that tells us, this doesn't mean that it's unphysical. It doesn't mean the science is wrong. There's no problem with that. What that's telling us is that these star systems started forming independently from 2 different nebulas. And as they formed, they also are gravitationally bound, so they started moving into one another. Now, what this star system is going to end up looking like is pretty messy. I will be surprised if you get any decent gas giant planets out of this, because you're going to have one accretion disk and another accretion disk all trying to fight each other's gravity. And as the two stars are starting to orbit one another, a lot of them are just going to get annihilated as we go. Difficult. The other cool aspect that they threw in here is the fact that you can see one star is pulling the gas from another star. And this is another thing that we see in astronomy a lot. So this also lends credence to the idea that you have two star systems that have formed independently, and now they're moving into one another, because the gravitational pull from one, the one that's up at an angle, is probably higher than the one that's sort of flat. And what's happening is, as that star is moving closer, it's starting to pull the objects away from that star. Not just the objects, but all the gas that's around that. And we do see this particularly with white dwarfs in binary stars, and we get flares from them. Because what happens is they're in a binary star system. One star has died, the other star is still going on, and the dead star that's super dense, thanks Susie, the star that's super dense starts pulling the gas off of the other star, and you get these weird X-ray flares that happen, and totally feasible. And totally almost exactly what you see here. Now, this is what most artist renditions look like, because we can't get a great picture because it mostly happens in X-rays, but still totally valid. So, oh my God, I'm not kidding when I say that there is tons to unpack just in that little picture. But let me see. So the mechanics are difficult. Gas is being pulled one star to another, and they probably formed as independent star systems, which are now started to merge into one another. And good luck figuring out what that star system is going to look like. Chances are the stars are going to start orbiting each other. The whole thing's going to turn into a big blob again, and then eventually flatten out over a period of time. But the formation of planets is going to be severely delayed because of this. So fun things. So as we're moving on, they throw out the term tech hygiene. Starfleet is concerned with tech hygiene, which is why they've been called out, because they have a broken interstellar comms relay. And this is also a thing that we genuinely worry about when it comes to exploring space. Us really on Earth concerned about. We noticed it just recently. Cassini, little Cassini. We miss you, Cassini. But Cassini was running out of fuel, and we don't want to leave interstellar debris. We don't want it crashing into planets that might have life on it. We don't want it crashing into Enceladus, because Enceladus has water under the surface of it. It's a moon of Saturn. We don't want Cassini just getting all tumbled around and crashing into it. So we don't really use the term tech hygiene like they did, but it's the same concept. You don't want dead debris going around, because Prime Directive doesn't just have to do with interacting with other species. It has to do with interacting with other worlds. And if our tech is going to crash into something, especially a new star system, then you want to clean that up. You don't want that hanging out around there. So they come to pick it up because Starfleet follows tech hygiene rules. Cool. Then they are trying to figure out what hit it, right? Where it's coming from. And they try tracking this object. Saru's awesome, by the way. Super fan already. And he's trying to find what could possibly have caused this, if there's any anomalies in this accretion disk system. And he says the scans are being deflected. That's a thing. That is entirely possible. We deflect scans all the time. Basically, all you need to do is just figure out a way to use diffraction or any other method that would bend electromagnetic radiation around you, so you don't have to see it. The recent tech that's come out of Rochester, I think RTI, I think, was the thanks for subscribing, Monty, was the idea that you can have two objects, one in the background. They're basically trying to develop a cloaking system, because we're nerds. And you have an object in the back, and then you use lenses to bend the light around it so it actually is cloaked. Now, we've not got much better than that. You have to be on an optical bench looking at it down one direction. But scans are being deflected is how we're trying to develop actual cloaking devices, because scientists are nerds. So as they study this, they discover that it's 150 meters long and it's tucked into the accretion disk. They actually say accretion disk. Woohoo! Science is right. And we're good with that. So the scans are all being deflected, whatever. This is what we call active scanning as opposed to passive scanning. So in science, in observations, passive scanning is when you just let radiation come to you. And if you have an X-ray detector or a microwave detector, any microwaves you're going to pick up, any microwaves you're going to pick up, any X-rays you're going to pick up, any visual light you're going to pick up, just anything that's coming at you. Active scanning is when you poke things and try to see the reflection come back at you, which is what they're trying to do to figure out what object this is in the accretion disk. They say it's in a sensor dead zone. So not only are the scans being deflected, but it's in a dead zone, which is kind of another way of saying it. Basically, you can imagine that their active scanning processes are being bent around whatever you've got out there. And so you're not able to actually hit it, have the light reflected back at you, have whatever radiation you're sending to it, whether X-ray, radio, microwave, whatever, coming back to you. It's dying out there. It's just being deflected and it's not coming back. So what do? They whip out a telescope, like an old school telescope. I was so excited to see this. Like, legitimately, we've not seen tech like this since Archer, which we're really excited about. And they're like, let's just use a telescope. Now, the problem is they already established this object is 2,000 kilometers away. So, yeah, woo! It's 2,000 kilometers away, which makes viewing with, like, a Galilean telescope not easy. So it doesn't work super well. It's still kind of fuzzy and doesn't, But shout out. That was a hardcore geek moment, which we appreciate. So Michael wants to go investigate this, and Saru mentions that there are high levels of radiation from these stars, from the binaries, valid, new stars, hot, and says that she has 20 minutes before her DNA starts to unravel. Not ideal. And, he says unravel like noodles, so be back in 19 minutes. I'm going to say that, even in 19 minutes, you're in trouble. And they do address that when she comes back. She does need to go to medbay, which I'm okay with. But, you're cutting it close. She kind of hit 20 minutes and ends up in medbay. So we'll kind of give her that. Well, thanks, Susie. So she says she'll be back in 19. And then one of the science officers on the ship says the temperature outside is minus 260 degrees Celsius. Not unphysical? Mohammed. More likely not lots of stranded DNA breaks. Does that unraveling count? I'm going to ask some biology questions. Because I was like, maybe it all just breaks. Basically, you don't want radiation to happen to you, because it's bad and does bad things. But yeah, you have ugly radiation out there. And the officer says it's minus 260 C. So that is the equivalent of 13 Kelvin. Now, that might not mean that much to you guys, but outside right now, if you're to leave Earth and not be in our atmosphere, the temperature outside is going to be 2.7 degrees Kelvin, which minus 260 is 13 degrees Kelvin. So there's a few things that we could deal with. First of all, 2.7 Kelvin right now, the reason our universe outside of Earth is 2.7 Kelvin is because it's ambient radiation left over from the Big Bang is heating up our universe, and that's what the temperature is. Now, 13 degrees Kelvin is high, and for space, that's really high, especially... Well, on this scale, it's probably not going to be much different from 2.7 Kelvin. So 13 degrees Kelvin, I'm going to say, is probably because we're near an accretion disk. I mean, you have an object tucked into an accretion disk that's only 2,000 kilometers away, so you're probably close to the two stars. They mention there's a lot of radiation coming from it. Yeah, DTG, I know it seems cold, but it's warm for space, which is weird. But given how much they said radiation is going to mess her up, and you have two early stars that are hanging out, maybe 13K, still kind of on this high end. But at least they didn't break physics. At least it wasn't less than 0. Before we get to that, Mohammed said, not sure what unraveling would happen in response to radiation, nor how bad it would be. Good. Okay. I am of the opinion humans are squishy and gross, and so I don't deal with DNA unraveling because that's squishy and gross. So yeah, we've got the temperature outside is physical, kind of warm for space, but also not insane. It's also not like it was, 40 or 50 degrees Kelvin. That I would have a problem with. So the next thing is she goes outside of the ship to go investigate this, and she's got magnetic boots. So if you have followed me at all, been to any of my talks, I super geek out over artificial gravity and different ways we can do it. Using magnetic boots. Oh, thanks for following, guys. There's a couple followers. So magnetic boots are a way to sort of have artificial gravity, just in the sense that you can walk around somewhat reasonably without wanting to cry is the way I like to put it. So she goes out with the magnetic boots. They're activated. We've seen this in Star Trek before. And then turns them off, starts to float away. All good. We're all good with this. Clock is ticking. She's exposed to the radiation at this point. And the object, again, is 2,000 kilometers away. This is where I become not fun to watch shows with because I get out my calculator. Centripetal force, yes, you could do it with centripetal force as well, but that would require rotating the whole ship at a certain speed that would not make things, it wouldn't be really worth it for the amount of fuel you'd have to consume just to rotate the ship enough. Thanks for following, guys. So when you demagnetize your boots and you start to float away, Aaron becomes not fun to watch movies with because I start calculating stuff. So the objects are 2,000 kilometers away. I paused it, and then I hit a stopwatch. And they mentioned on the show, she was 1,000 kilometers. So she was halfway there when my timer said 58 seconds from pushing away. Now, there's movie time, and there's Aaron time. There's two different ways they do it here. One is that what we're watching is real time. The other one is what they're telling us is real time. What they're telling us is probably more appropriate, but we'll start with the real time. So me watching it with a stopwatch, saying how far it takes. So it took her 58 seconds to get 1,000 kilometers. That's going 1.7 times 10 to the 4 meters per second, or 0.005% the speed of light. Not terrible, but pretty fast for a person. And then the other one is they mention 6 minutes have passed and when she's halfway. So that came out to 5,000 meters per second, which is about 12,000 miles per hour, which is also very fast, but not breaking physics. I was mostly trying to see if it would end up being faster than the speed of light, or close to, like, once you start hitting 1% the speed of light, you start getting weird relativistic things. I got a ton of followers in that segment there. Thanks for following. I appreciate it. While I geeked out over all of the math that I did while I was watching this show, the calculator came out. No one watches shows with me. So the other cool thing is when she gets to the anomaly, right, which we discover is a Klingon ship, the boots work, which says something. That tells us that the whatever metal alloys they have are magnetic. The same, not necessarily the same metal as the ship she's coming from, but have the same properties, which is kind of cool and, necessary to think about. So then we get there and her technology is awesome. she's looking around. As she's looking, the scanner on her headpiece is following her eye movement. They're trying to develop this for VR. So this isn't insane, where you have computer feedback that's looking at your eye movement and it's tracking where your eyes are looking and moves your scanners in whatever respective direction. So if you notice, as she's looking around, if she pauses on something, she might hit something or carrying on, but it scans it. That's how she figured out it was Klingon and like a cool looking bat'leth, by the way. Cool bat'leth. But scanned the bat'leth because it knew that's what she was looking at because it was tracking her eye movements. So that's kind of cool, and that's actually technology that we're trying to develop right now. That was exciting. Then I couldn't get a good image of this, but if you remember, once she's here, she's stuck in that sensor dead zone. So Michael's lost. Captain Georgie's like trying to find her, trying to get her signal. And she tells Saru, boost her signal. And he's like, there's no signal. She's like, I don't care. You better give me a signal. He's kind of like, ugh. That is actually a way you can do things. So if there is no signal, but you know what signal you should try to find, you can use a technique called matched filtering, which means if your signal looks like this, it's a nice fixed signal, and you have a ton of noise that's just blurring the whole thing. There's no signal in there, but you know what your signal should look like, then you can multiply that signal through all of this crummy noise and actually amplify it and get a signal. So it kind of sounds like science technobabble, but that's actually something that we do. Yeah, 1940s signal processing for the win. No kidding. Like, this is actually a thing. And like I said, it sounds like technobabble, but this is what we do as scientists, which is pretty sweet. So yeah, matched filtering, use it all the time, trying to dig out signals. Been around for a long time. Cool stuff. Okay, then we're on the Klingon ship, and they have their dead Klingon, and they send up his sarcophagus. And if you haven't followed Popstar Klingon, I highly recommend you do that on Twitter, because she did a whole breakdown of the Klingon language in Discovery. Huge fan of. But apparently at the Klingon language conference, they were trying to come up with a word for sarcophagus, and no one knew why, and now they know why. But when they send up the sarcophagus, I was trying to figure out how they were doing that. That they were somehow turning off the local gravity to let it float up, or maybe they were just using a tractor beam technology to go up, maybe. There's a few ways that you could interpret it. I'm probably going to go with turning the local gravity off, simply because when we use tractor beam technology, we tend to see it somehow. So we're going to go with turning off local gravity. Yeah, all right. And then the sarcophagus goes up and it leaves the ship, and then it attaches to the outside. And it was like a weird material on the outside. I think I've got it. Yeah, I've got a picture of it. It was like weird. I didn't know if it was like some weird sarcophagus goop or literally just local gravity on the surface of the ship. Either one is possible. We'll go with that. Still, just kind of weird. Made me think about it. Interesting. All right. And then carrying on, Michael comes back. The anti-proton therapy was complete. Humans are gross and squishy. I will leave that to my biology friends to figure out how they use anti-protons for radiation therapy. I tried to do some physics of it, and I stopped. Squishy. All right. Then they're looking at this, and they're trying to figure out what's going on. And as Michael's running back to the deck, quantum efficiency spectrum was on there. I was like, oh, pause, screen cap. What the hell is a quantum efficiency spectrum? If you guys have any ideas, bring them on. They said that the binaries are kicking off some serious QEs up and down the spectrum. Technobabble? But not insane technobabble. Like, it could make sense. It's not nonsense. But I want to know what units those are in and what it's referring to and how they're detecting them. So One day we'll figure it out. And Klingons show up. There's no warp signature. If you've seen me talk about tachyons before, you know that warp leaves behind residual tachyons because they're breaking physics, and so tachyons get left behind, which are what warp signatures are. And the Klingons just decloak. They've been there. And they talk about Kahless shining in the sky. So I'm not going to get into Klingon mythology as much as I want to. I'm not going to get into that. But they're talking about a star. And as we go, weird stuff starts to happen. So before I go into the light of Kahless, I'll give another shout out for my biologists, because Saru comes from a planet that has a binary species map with no food chain. I'll leave that to you guys to figure out. You're either predator or prey, one or the other. Squishy. All right. So, carrying on from that, light shows up. Light. Bright light. Light with units. They used units. So my science brain kicks in. And they said, so we've got the light of Kahless, this beacon that they're using. And then you have a high-pitched sound. So there's two things to break down there. The first is the light. Science officer, I assume it's the science officer, I think he was a tactical officer, refers to it as 1 billion lumens per meter squared. Lumens per meter squared is a thing. It's otherwise known as lux. If any of you have done photography or cinematography, you may be familiar with lux. That's lumens per meter squared, and he says it's 1 billion. So what does 1 billion lux mean? Do we have a reference for that? We do. The sun, direct sunlight here is 100,000 lux, 100,000 lumens per square meter. So what that means is that what they are seeing, 1 billion, 10 to the 9 compared to 10 to the 5, they are 10,000 times brighter than sunlight. Does that exist? Yes, it does. It's actually... There are objects that are about 10 to the 4 times brighter than our sun. They're called Wolf-Rayet stars, and they are typically when stars are going through their life cycle, they start burning through the hydrogen, and then when they burn through all the hydrogen, that kind of filters through and it gets converted into helium. And Wolf-Rayet stars are primarily helium stars, and they're about 10 to the 4 times brighter, or 10,000 times brighter than our sun. So this is a star. This is a light equivalent of a star, a very bright star. And as Sarek mentions later, he says your quadrant reports a new star in the sky. Valid. It would be classified as a Wolf-Rayet star. And if they didn't know that it was artificial, it would be a Wolf-Rayet star. Now, the other thing that happens is there is a huge amount of sound that's coming from the Klingons. And if you remember, they all cover their ears. And then she's like, make the sound go away. He's like, I've done it. The ship's superstructure is in sympathetic vibration with the sound. Oh, yes. Basically what he means by saying that is that it's in harmonic frequency with the sound. So you have your whole ship's structure, and then you have the sound that's pounding on it. And what happens is, like the Tacoma Bridge incident, the sound is hitting it and it's amplifying these harmonic frequencies that's making it get louder and louder. So even if you're able to like hit the sound somehow in your own ship with a inverse sound wave, like a sound wave that's complementary to it, to make it go away, it still could vibrate your ship if your ship is in harmonic frequency with it, making it difficult to go away, because then your ship is vibrating at that frequency, which is emanating sound waves. So even if you can mute the source, your ship still could be emanating sound waves from it. Kind of cool. Harmonic frequencies is what he meant by when he was talking about that. Okay. Then the episode ended, and I was exhausted. There was so much science, and new Star Trek, and Klingons, and Klingon war, and new characters, and new ships. But episode 2 started, if you had CBS All Access. So I'm going into that now. If you didn't watch it, there's not a ton of science. I'm not going to you're not going to miss out too much on that. Oh, thanks for the follow. Basically kicks off. We go into a lot of like Michael's story and history and stuff. All cool. Not much science in it. And but Klingons start firing, and there was a pretty cool. I had a hard time getting a good picture of it, but like there was a really cool plasma burst from the Klingon ship. Star Trek deals with lots of different technobabble weapon systems, photon torpedoes, proton torpedoes. We have seen both. Plasma beams, all sorts of fun things. This was kind of clearly and awesomely a plasma burst where they collect a bunch of plasma and shoot it there. So if you're not familiar with what plasma is, if you remember in school, solid, liquid, gas, there is actually solid, liquid, gas, plasma. Plasma is super, super hot gas. And yeah, it's a form of matter. And you could use it as a weapon because you don't really want to play with plasma, which is why we probably don't learn about it at school, in elementary school at least. So plasma burst from the Klingon ship. Yeah, maybe you guys will have some idea for this, but how does the shield technology work here? I don't understand. So they're starting to get pummeled, and this technology is going through the ship, like punching holes in the ship, actually like breaching hull, like hull breaches are going on around the ship. And then Saru says yes, plasma is ionized gas. When you superheat gas, then it becomes ionized. So basically, as you're heating it, it gets so hot that the electrons fly off of it, and then it's ionized. So yeah, that's okay. You can hang out with me. We'll talk math and physics. You don't need to go back. So yeah, plasma bursts hit it. But they're punching holes in the ship, and then Saru's saying that their shields are at 100%. So maybe they're referring to the fact that like force fields are able to fill in the holes. Maybe that's what they mean when they're talking about shields, but that's contradictory to like all other shield technology that we talk about. Because I don't know how many Star Trek games that you've played, but even Star Trek board games that I've played, the shields go first, and then the hull gets hit. And the hull was getting breached, and the shields were intact. Yeah, I hope there's an explanation, but I'm super confused with the shield technology, so we'll hang in there. Okay, so one of the cool things that they showed was the rapid decompression. So the poor guy who was, I think he was not tactical. Anyway, he was one of the pilots. He got injured, got the concussion, was trying to find medbay, went and found her in the brig, and then tore through the hull. Rapid decompression, and force fields went up around her cell. Still how the timing works. Question. Set after Enterprise writes, some confusion between polarized hull and TOS TNG level. Yes. And I think like the polarized hull is kind of what they're talking about when they're squishy biology does not like rapid decompression, correct. But with a polarized hull, so that's when stuff flies through it. Compared to energy shielding, yes, but they talk about force fields separate from the shield. So this is why I was confused, because they were saying like the force fields are intact. Or the force fields are functioning and the shields are intact. And it wasn't quite clear one or the other. But maybe I need to think more along the lines of Enterprise. Now I have to go back and watch all of Enterprise. Thanks. So yeah, rapid decompression happens. Bad for squishy things. Squishy things go bye-bye. I would love to know how quickly these force fields are able to fill that hole. Because basically what happened, like if they can protect her, why couldn't they protect him? Was it just that he took a direct hit? Possibly. That might be the reason. It's sad, but the imagery was kind of cool though, of that force field and the rapid decompression. So then this happens. Sarek comes to her in a very ethereal Star Trek Vulcan magic sort of way. No bending of space-time would be happening here. This is all in their minds. But it does start to damage him. Remember, he's like, why would I risk my health to come and talk to you? I like to think that there's some weird quantum entanglement. Yeah, correct. I wasn't wild about it. But if we're going to be throwing science at Star Trek, then I'm going to throw some quantum entanglement at this. And I'm going to say that maybe what happened is when he Vulcan mind melded with her as a child, then somehow, wibbly wobbly, timey-wimey stuff, somehow you create a entangled quantum particles between the two of you. This is a huge stretch. Sorry. But it's the only way I could think of to possibly justify how this could be happening. Because all other Star Trek usually has some scientific explanation, even if it's warp drive, even if it's bending space-time. This didn't. The best I could think of is possible quantum entanglement, that if he can access the entangled particles with her. So for those of you who aren't familiar, you take two particles that are entangled, or you take a particle, and you can split it into its subsequent components. They stay quantum entangled. It's still weird science that we don't quite understand. But what happens is you can move those particles as far apart. Well, we try to move them as far apart as we can and keep them in that state. But in theory, and as far as we've been able to see, if you keep them in that state, you can move them as far apart as possible, and they can react to each other faster than the speed of light, instantaneously. They don't need to communicate a signal. There doesn't need to be a cause and effect sort of communication at the speed of light to say, hey, I'm moving. And they go, oh, I'm going to move too. They just move at exactly the same time. And that could be how you do this. I could imagine it wouldn't be great on the brain if somehow your brain is quantum entangled with another person's brain and you're able to tap into that to communicate some sort of weird language, Morse code, neurons firing thing. Yeah, can't justify it, but wanted to talk about it because it was kind of weird and a stretch. So then they say the force fields are holding, but the shields are offline. So that screws up the other part of it. So far, the only two big issues that I have is the stardate retcon, new stardate system, and force fields versus shields. To be continued. We're going to keep an eye on this. So, carrying on, they let them go. The Klingons start to let the ship, destroys all the other Starfleet ships. They get left behind and abandoned because they start falling into the gravitational pull of the binary star system. You got two binary star systems. The cool thing, I'd kind of have a bit more of a problem if they didn't have the visuals the way they do now, where you have all of the asteroids and the debris hanging out around the stars. So they are legitimately within the gravitational pull of those binary star systems. Now, how long it would take them to fall into one of the stars or the gravitational equilibrium between them would probably be a long time. But thankfully, as it demonstrated, the bigger issue would be running into a big protoplanet object or big asteroid. At this stage, they're all kind of asteroid level. That thing that they're about to run into looks like the biggest one in the region. That'll probably end up being a planet one day. Kind of fun to think about. Right, I agree with this. It's not very Klingon to let the stars finish off the enemy. The Klingons were behaving a little bit weird, and I'm not. We're gonna find out about that. 3-4 new stardate systems. Yeah, consistently inconsistent. There we go. Just throw new stardates at them. Same with the warp levels. Like warp 1 doesn't equal warp 1 later. That's fine. It's fine. Yeah, so maybe that was the inside joke. We're doing a new stardate system. I like that. We'll go with that. Okay. So getting sucked into the binary star system. Gravitational field being pulled in. Somehow the Klingons are letting the stars finish them off. Then, the holo communication systems that they use. Basically augmented reality. I mean, that sentence didn't really make much sense a few years ago, but now we use AR so much. Like, we're building new AR stuff. You could almost think like if they have universal translators, maybe they have universal AR systems that are able to view holo technology. It's kind of the way I'm looking at it. Now, at one point, the holo image of Sarek leans on the desk in Michael's office. That's a bit tricky. You'd have to have like dual AR, understand where things are, and then have them physically present, which we know holo technology later can, but this definitely looks more like hologram communication back here. So, we're okay with that. Then the Klingon ship shows up, tears through Europa. That's what's going on here. Kind of cool. That was kind of a cool visual. Even though as soon as they hit it, the cloaking system didn't go away, which I feel like would happen. But I feel like there are definitely examples where we have seen cloaked objects stay cloaked when they run into stuff. But I can't think of any right now. If any of you have some, throw it at me. Oh, thanks. So yeah, then let me see. Oh, then Michael needs to get out of the cell. And there was some fun play logic games with the computer type thing. Yeah, all right. And says you've got 6 seconds, or your exposure to vacuum will be 15 seconds, which I think the computer was counting if you run from there to there, which isn't great. But as Michael rightly said, if they open a hole, there would be rapid depressurization, and it would shoot her towards the door in less than 6 seconds. Yes, I did have the picture where she was flying at the camera and you saw her start to like ice over and her eyes start to bulge out, but it looked terrifying staring at me when it was frozen, so I've not gone with that. So you can kind of see her shooting out of the hole right there, because the other picture was legitimately terrifying that I didn't really want to be staring at for any period of time. So, as they correctly say, if you are in a vacuum, you will result in respiratory distress, shock, and suffocation. They didn't mention blood boiling, exposed to a vacuum. Your eyes would definitely be bloodshot. If I were her, I would have closed my eyes and just hoped, because you don't really have a whole lot of control over what you're going on. I would close my eyes and my mouth and probably my nose if I was going to be in the outside of space for less than 6 seconds. I feel like this is going to become one of those things once we actually start studying or actually start going into space and exploring it as a normal human thing to do. They're gonna have to go back into a lot of like sci-fi and say, by the way, don't do this, you will die. Because like Battlestar Galactica did it. Like, oh, you'll be fine real fast, we'll catch you real fast and you'll be fine. Yeah, I wouldn't mess with that. So she gets to the door in less than 6 seconds. The door is open, she gets pulled in. There was no nasty depressurization happening. She was fine. Her eyes probably should have been more bloodshot than they were, but ultimately she was fine. And then let me see. Yep, we're hitting an hour almost exactly. Awesome. So the last thing that they did that was pretty cool science-y wise was beaming the photon torpedoes into the bodies of the Klingons, which was awesome. Again, they were trying to come up with a way to breach the hull, like transport it there, but the shields are up. So how can we get the bomb onto the ship, or the photon torpedo onto the ship, the warhead, and they just put the warhead into the tractor beam, which gets pulled in. And initially, I was kind of like, ooh, maybe would that really work? Like, if you have a tractor beam, could you beam something into a tractor beam? But I didn't really need to worry about that, because actually, if you look at it carefully, it gets beamed in and then immediately gets pulled into the tractor beam. So we're kind of okay with that. And then it goes off as soon as they hit the ship, which was awesome. And then Georgiou got stabbed and lots of weird things happened. And story-wise, how did everyone know there was a new star within minutes after the beacon was lit when they were presumably light years away? Great question. So yeah, as they mentioned, what was the closest thing to them? There was they mentioned the Andorians and the Starbase. Is that what they said? I think it's called something else. or we have a few questions. I'll do that one first. That they were like 1 or 2 light years away, and they said it's going to take us 2 hours for Starfleet to get to you. Yeah. However, they do have an interstellar comms relay, so maybe they've got some things set up there. Maybe the other thing may be the idea that if you have a Starfleet ship in a region, it will have sensors to pick up high amounts of radiation, and that much, a billion lux, that would definitely set off a thing to just maybe say within the Starfleet ship comm relay, which is a subspace relay, to say, hey, there's a new star, like there's a new star in the region, something was ignited, there's new radiation present around us. So that would be possible. And then the next question, but good critical thinking, and I think I'm probably going to say that there are probably sensors on the ships, like astrometric sensors, speaking Star Trek, that would alert a subspace communication system to say that there is another star present. We'll go with that. And it would map it. We saw astrometrics a lot in the past. So wouldn't she be pushed away from the ship when the hole on the other side opened because it would depressurize too? Yeah, and this is what I was wondering about. I legitimately had no idea like how that would actually work, because if the door opened to let her in, then the air would be rushed out of there. But it did look like there were two, so there was like the force field and then the shield doors hit. And it could be possible to time it so you would go straight in. But you got to remember, she also has conservation of momentum on her side. So even though you got a lot of air flying out, she's got a lot more pushing against the air. So she'll feel the air rushing out, but I think she could actually overtake it and end up in the hallway. Okay. Yeah. You'd have to do the math. I'm going to write that down. I'm going to see if I can do the math for that. Hallway depressurization. All right. And then what was the other question? How do they communicate perfectly fine when the beacon is ruined? What is the beacon for? So yeah, I kind of mentioned that a little bit at the beginning. If I didn't go into tons of detail. So if you were here, then I apologize for not explaining it very well. So the interstellar beacons, they're basically comm systems. And what they do is they create a relay through subspace. So just briefly plugging my other videos, because I can. But some of the VODs that I have to do with how our universe is shaped in space-time and faster than light travel. And subspace comms relays, I'm going to do a whole episode on it. I've not done it yet, but I'm going to move that up the chain because of this. How it works is if you want to have communication straight on the universe, it has to follow along the surface, and you go fast at the speed of light. If you want to go faster than light, you have to punch through. So basically you make little wormholes between each one that you can artificially make. So think of them like stargates or wormholes or point-to-point communication systems, mass relays if you've played Mass Effect. Those would be the equivalent subspace comm systems. Now, they wouldn't be enough for any objects to get through. They would purely be a sort of point-to-point bending of space-time through subspace. And when we say subspace, we talk about our universe being a flat sheet. Subspace is what's under or above that sheet. So you can artificially bend point-to-point systems and communicate that way. So now that beacon, what I suspect is, so again, Mass Effect is probably the best analogy to use for this. So if you have an interstellar comms relay, you're going to be using these point-to-point systems. Just like in Mass Effect, when you try to travel from one part of the galaxy to another, you see all of these paths because they are already built point-to-point systems that you have to follow that path through. Now, interstellar comm relays would be doing the same thing. They would have point-to-point systems that are just opened enough for a communication signal to go through. And if one was down, then that would break part of the chain. Now, ships, they have separate systems. The Starfleet ships, I think, are tapped into the interstellar comms relays, but I think they also might have quantum entanglement communication with Starfleet itself, which is kind of what I assumed was going on. I didn't think that they were using that comms relay to communicate with Starfleet. I thought they were using their own ship communication, which doesn't necessarily need to use the most nearby comms relay. So we're going through that. Did they address the computer's problem with her not being able to open the door? The logic one. I didn't really go into it. It was kind of, it was just a logic game for a computer, right? That it was saying, well, you have to help me if I'm in distress. And the computer says, well, you're not in distress. You're assuming that you're going to die in 8 minutes when this goes out. But you're not for sure. You're making that extension. And then she kind of points the computer to the idea that, she will die in 8 minutes. I personally feel like the computer would be able to use that as a scenario, and actually, as famous other series would say, don't tell me the odds, more put together all possible scenarios and calculate the odds of survival, just like it did a split second later when it said the odds of survival are like 47%. You'd be able to do the same thing and say if it's above a threshold, then you can get through. So I'm not going to really address the logic system of the computer because I feel like it shouldn't have needed to be talked through it, but still kind of cool to see. And ultimately, the decompression stuff was awesome, and I would still do the same on computers. Pretty sure she would be so would that be possible? I think you asked that question when I was talking about the interstellar comms relays. We don't have that technology now, but I always say this because I'm a sci-fi geek and my background's in general relativity, so this is kind of what I talk about. The math would work in order to build an interstellar comms relays with doing point-to-point, like wormhole jump gate type systems. Jump gate systems throughout space to build a network that actually is not confined to the surface of space-time of our universe, that it could do a subspace relay. How you would do it, that's for the engineers to figure out. The math works. In theory, that's how it works, but we don't have the technology to do it yet. So we got to figure that out. Get on it. So pretty sure we'd be able to build rule sets the other way around. Yeah, computers. Agreed. Overall, I liked it. I don't know if you guys have any more questions we can do. Would it be possible to do subspace radio or only point-to-point communication device? So correct me if I'm interpreting this wrong. Subspace radio, when I hear that, I'm thinking that you're beaming a radio signal through the point-to-point communication system. So you have all these comms relays that are set up, and they are able to send a radio signal through them that would take it still takes time. It's not instantaneous, but it's faster than just traveling along the surface would be. If you're thinking maybe like beaming out a radio signal in a uniform direction in subspace, you could, but it wouldn't go anywhere. You wouldn't know that you could receive it. So that's the tricky part of that. But all of those point-to-point communication systems, I kind of interpret as using traditional electromagnetic radiation, radio, microwave, whatever rays, through these little confined comms relays. Again, I hate to keep coming back to it, but like Mass Effect is the best. I don't hate to keep coming back to it, but you might not have played Mass Effect. But they have like the galaxy map of all of the places that you could go, that you have to follow this path. You can't just say, I want to go from here to here. That is going to take you through a already predestined track where you have these wormholes set up. And like I said, for my weekly VODs, I'm going to try to record this and maybe put it out within the month. I have a few coming out before then, but hopefully if I can get a good episode together before the end of October, then I'll try to do a whole episode on subspace communications and how that would work. So yeah. Anyway, any other questions that we got? Tuned in late. Do I like the new Klingons? Yeah. I've not really gone into like what I thought of the series personally. I do like the new Klingons, and like I said, I follow Klingon pop pop star on Twitter. She speaks Klingon, and she loved them. So I'm willing to kind of follow her lead on that. But yeah, I thought they were cool. I'm curious to see what they do with it. Obviously, I mean, it's the first episode, right? Like, you're going to have to build characters. I had such a hard time with the first episode of Deep Space Nine, and it's my favorite Star Trek series. Sorry, I don't mean to start anything, but it's my favorite Star Trek series. But honestly, I had such a hard time with that first episode because it was Cisco focused. You didn't really build up a lot of the characters quite yet. Like, Bashir was a pretty flat character for a long time. So if they can make some cool characters out of these Klingons, like, I'm good with it. And I like the idea that we're exploring the Klingon War, and I like seeing the different houses, and we'll see where that goes. So, excuse me. Do you think Sarek's psychic communication with Burnham will result in developing a mental disease? Oh, I like that. Okay, we're getting into Star Trek nerd talk now and less away from the science, but bring it on. Oh, I like that. I'm so curious to see how they tie Sarek in, because, like, so I was thinking about this. Most of especially DS9 and Voyager, tied directly to previous, because they were also later. Like, they were all within sort of the same timeline. But I really want to know how Sarek develops and how they tie him in with Spock, and like if we meet his wife and their relationship, because I've read Spock's World and I love Spock's World. So I'd really like to know more about Sarek. It's great. Red Bear Real says Luke learns how to be a Jedi. I shouldn't say anything because I've got I'm sitting in my Star Wars room, so my loyalties are equally divided. Bendy Syndom. That's yeah. God. See, now maybe I should read Spock's World again and figure out, because I think they talk about that with Sarek. But anyway, we could talk a long time about all of this. Were there any more science questions that we want to talk about, if anyone else? But yeah, that would be really cool if they are able to tie in his issues with communicating with her. But if they're going to do that and say that that's how he developed his mental disease, they're going to have to go way more into the science of how that actually worked, because I'm so sorry. I don't understand it. So if they're going to tie that into the mental disease, I hope they actually go into it. But yeah, no, thank you. Maybe they're going to have a Vulcan part of the story. And I mean, he took care of Michael. She's human. It showed kind of he's got that affinity for humans. So maybe that was it. But yeah, no, thank you guys. Thank you guys so much for coming. I'm going to be doing this the same time next week. Let's keep our fingers crossed that there is some science next week as well. And again, feel free to follow me. It's September. If you want to subscribe, I'll be rolling out some subscription level perks next week. So if you want to keep an eye out for that, it'll be before September ends, so you get a subscription for half off. Also, if you have Amazon Prime, you can use that to subscribe. Do a 1 month subscription to me if you so choose to spend your one subscription from Prime. And yeah, thank you all so much. This was really fun. So follow me. You can also follow me on Twitter at Dr. Aaron Mack, same handle here. And you can follow my YouTube and Twitch VODs that I put out on Thursdays. So I'm still trying to decide which one I want to put out this week. I already have a few recorded, but I want to decide which one to put out. And yeah, keep an eye, follow me, and I'll do this the same time next week. And you can also follow me. I randomly will get on and stream. So thank you guys. Thanks for the follow, and I'll catch you next time. Oh, thanks. Yeah, 4 a.m. is pretty early, but you can watch the VOD. All right, have a good night, guys, or morning or day, wherever you are. Thanks again for hanging out. This was really, really fun, and I'll catch you next time. See ya. Live long and prosper.